Assalamualaikum.
Today we are going to look at another chapter in our course, which is chapter 4. This chapter is covering the topic of search. So in this topic, we are going to look at several parts. First, we are going to look at the structures and strategies for state space search, or for short is SSS. And then we are going to look at several algorithms in searchings. So the first algorithm that we are going to look at is backtracking search algorithm. Next, we are going to look at two blind search algorithm, which is breadth first search, BFS, and depth first search. The next one, we will look a little bit on heuristic search. In heuristic search, there is three algorithms that we're going to look at. The first one is hill climbing. The second one is best first search, and then we will have A-star algorithm for heuristic. Besides of these search techniques, we are going to look at heuristic search, which is applied in games. Two techniques that we are going to look at in this topic is minimax and alpha beta pruning. Okay, let's see how do we represent the state space search. Usually in state space search, we are doing some search on top of some trees. So trees are represented in the form of a graph. So a graph should look like this. For example, we have A connected to another node, which is called B, for example. And then we can have this A connected to another node, C. It might have another node connected to it, which is D. So when you have this kind of representation, usually each of these have different value to us. So this in circle, usually we call it as nodes, and these are called as arcs. So node is representing the states, and arc is representing the transition between the states. So you can have a node connected to another node using an arrow. So this arrow is called an arc. Okay, so in an arrow, these can have some relationship, which is this is usually the parents. The upper level are usually the parent, and the child will be under it. Okay, so if it has some other nodes under here, so it kinds of a grandparents thing here, and we can say that B and C here are siblings because it actually go back to the same parent. Okay, and we also can have some kind of like we have another node here. For example, I have E and F. So in this case, we called the E and F as a leaf node. Why is it called a leaf node or tip? Because it does not have any more child. Okay, so B is not a leaf node, C is a leaf node, and D is also a leaf node. So this is how represent a tree in the space search, and usually this is called a graph. Okay, now let's look how do we represent the state space representation in the problems. Usually a state space is represented by a tuple, found tuple, which is an NASG. If you look at this tree, you can see the NASG. N is a set of nodes in the graph. So you have a set of nodes here, A, B, C, D, E, F. So these are the nodes. And you have a set of arcs, which connecting all the nodes. So you have AB, AC, AD, BE, and BF. These are the arcs. S is a non-empty set which contains the start state. For example, in this graph, we are trying to look at how we can move from A to F. So A is the start node, so A is the S, and we have G, which is the goal state of the problem, if we say we are going to from A to F, so F is the goal state. So this is actually one state space representation. In a state space, we also have a solution path. A solution path is a path through this graph from start to end, to the goal. So we have here A, B, F is the solution path.